In the previous part, I told you about my self-propelled trip around Vancouver Island and compared its environmental footprint to driving. Here, I'm going to dig deeper into the science behind the comparison. If you're looking for something specific, there's a clickable outline down in the description that will get you where you want to be quickly. Okay, I was comparing my trip to an imaginary one in which I drive instead of biking. My self-propelled loop was 1,200 kilometers in total, and it took me 18 days. If I drove, I could have done it in 14 days, but the total distance would be longer because I would need to shuttle my car for the hiking traverses in Strathcona Park and at Juan de Fuca Trail. In the first video, I mentioned greenhouse gases and land use, but I didn't have time for water use and pollution. Here, I'll start with more details about greenhouse gases. Roughly speaking, driving is double that of biking, which isn't that much when you think about it. The numbers are a combination of transportation and food production. The transportation part includes the emissions that come from tailpipes of cars, buses, and ferries, but also the upstream emissions that happen when oil is extracted, refined, and distributed. What comes out of tailpipes is more than the upstream emissions. I assumed that the oil came from the oil sands in Alberta, which makes the upstream emissions slightly higher than for other oil deposits. I know that fuels in BC do not come only from Alberta, actually only very little does, but I wanted to use this opportunity to learn more about how bad the oil sands really are. I'll be getting back to these questions throughout the video and then at the end too. The food part of the footprint contains all the emissions that happen between the farm and the grocery store. It can be the carbon dioxide from burning diesel in a tractor, nitrous oxide released from fertilizers, or methane from decomposing manure. All these gases are greenhouse gases. You should know that I didn't include the emissions from manufacturing of bicycles, cars, or any other equipment. Moving on to land use, you might remember that I said it mattered quite a lot for my comparison of biking and driving. I think the keyword for understanding why land use is so important is change. Before cities, roads, and agriculture filled the planet, it looked quite different. Now, agriculture takes up 43% of the land that's not a desert or isn't covered in ice. If I had driven, I would have eaten less, which means that I would need only about 2/3 of the land for growing food. I'm going to visualize what more or less land use means, but remember, the illustrations are not at scale. Less agriculture means that more land could be set aside for protection and offer a good habitat for wildlife. Scientists are not afraid to say that we are in the middle of a massive extinction event and that land use change is the main culprit. The good thing is that they also suggest how to fix it. We need to do agriculture right. And here's an example. The left picture is a single crop field with heavy pesticide and fertilizer use. I don't think that too many animals would want to live there. The right one has multiple crops, trees, and the farm tries to recycle nutrients and limit using pesticides. I can definitely see some animals living there. Land use also affects how water flows through a landscape. After the rain, the water with bits of soil rushes from the fields and makes flooding more likely downstream where we live. Lakes and wetlands in untouched landscapes hold the water and release it slowly without washing away too much soil. And because everything is connected, changing the land also changes how it interacts with carbon dioxide. Forests generally hold carbon, but when we cut them down, the carbon will find its way from the wood and soil back to the atmosphere, where it affects the climate. For my trip, most of the land use comes from the food I ate. The number includes all the cropland and pastures. The small piece at the bottom comes from the transportation, and it is a combination of the area that is occupied by the oil sands facilities in Alberta and the cropland for growing corn that's used for making the biofuel that's blended into gasoline. As I said before, I was curious if oil sands up in Alberta are really that bad. and it seems that their land use is much lower when compared to agriculture. I'm not saying that the impact on the boreal forest is negligible, but for my trip, the land that was taken by the oil sands facilities is much smaller than that taken by all the fields on which the food for me was grown. Again, more about this at the end. Before I move on, I have to add that I didn't include the roads, pipelines, or any other infrastructure in the land use number. Moving on to water use, it'll come as no surprise that irrigation and agriculture needs a lot of water and that my footprint was mainly because of the food. It may seem irrelevant to even mention water when talking about a trip on the rainy west coast of British Columbia, but there's a catch. An avocado that I put on a bread somewhere on Vancouver Island was grown in California or Mexico, and water down there is much more precious. Water was needed for producing the transportation fuels too, in particular for extracting oil from oil sands and for growing corn for ethanol and gasoline. Looking at the transportation part of the water footprint, it seems that even though oil sands have been blamed for high water use, it is only a little bit in comparison with agriculture. And just to be clear here, I didn't include the few liters of water that I drank every day because they are negligible in comparison with tens of thousands of liters for growing food. I also neglected any water used in manufacturing of cars or bikes. And now, the pollution. That is the trickiest one. Oil sands can cause spills or release heavy metals and other toxic chemicals into waterways. But in agriculture, rain washes away fertilizers and pesticides that also pollute the waterways. I didn't know how to compare the two, let alone where to get the data. So unfortunately, I can only say that comparing the pollution was beyond what I could do. And finally, here come the results. In the first video, I told you that my biking trip had a lower carbon footprint than if I had driven, but also that I cannot say that it was better for the environment. Here's why in a bit more detail. Biking means less greenhouse gases, which is good for the climate and the oceans. But biking also means more agricultural land use, which is bad for animals, forests, and fertilizer pollution. Biking is also worse for water availability. I was tempted to say that climate change is more important than the others and that biking is better. But then I came across the concept of planetary boundaries. It is a rating of how much abuse has our planet taken and how close we are to serious issues. The climate is in the yellow zone and the oceans are almost there. What I didn't know is that animals, forests, and fertilizer pollution are in red and yellow zones. In other words, there is no doubt that things have gone off the rails there. Water availability is in the green zone. So biking was better for the climate and the oceans that are in the yellow and green zones. But biking was worse for animals, forests, and fertilizer pollution that are in the red and yellow zones. Biking was also worse for water availability, which is in the green zone. In my eyes, that means that I simply cannot say that my biking trip was better for the environment. Maybe someone smarter who understands the planet more would be able to make a different conclusion, but I couldn't. In the first video, I may have surprised you when I said that a vegan in a nice car could be more environmentally friendly than a beef-eating bicyclist. Here's how I came up with that claim. The results that I'm showing you are for an average car and my diet. If you're wondering what my diet means, here's what I ate, split based on calories. If I drove a fuel-efficient car and ate a plant-based diet, my footprint would be lower. By a plant-based diet, I mean replacing milk and cheese with nuts. That would basically mean buying almond chocolate milk instead of normal chocolate milk and eating bread with peanut butter instead of bread and cheese. And I guess more trail mix for snacks. When I was playing with imaginary scenarios, I didn't need to think twice to come up with what I would need to eat on my biking trip to make the footprint higher. We hear quite often that meat isn't that great for the environment. Salami and sausages don't go bad too fast, and taking them on trips is quite common. So I tested what would happen if I replaced the cheese in my diet with salami made of pork and chicken. It was quite surprising to see that the footprint would be lower. That means that dairy is not that great. And it was obvious what I was going to try next. What if I ate burgers and beef jerky instead of cheese? I had heard before that the carbon footprint of beef is high, so it wasn't too surprising to see that eating it would make biking worse than driving. But I was surprised that the land use got so high, especially after learning how important it is for the health of our planet. And that was the name of the game for this project. Surprises. I knew that producing food puts a lot of strain on the planet, but I was surprised to see how bad it is in comparison with driving. I knew that meat isn't that great for the environment, but I was surprised to see that dairy can be worse than some types of meat. And I was definitely surprised when I found out that greenhouse gases really aren't the only thing to compare when figuring out what's better for the environment. Let alone that figuring out what's better for the environment is really tricky. And yet another surprise was the impact of oil sands. Their land and water use turned out to be quite low in comparison with agriculture. I know I'm opening another can of worms here, but I need to try to make at least some sense of it. I was entering this topic thinking that oil sands should be worse. I think it's because the environmental groups may have inflated the claims about how much boreal forest is affected and how much water the oil sands use. The oil companies campaign that they use only a teeny tiny fraction of the boreal forest and that their actual water use is actually very low. And by doing that, they can move the attention away from the important topics. How are we supposed to navigate this mess? I don't know. I just hope that those who make decisions for us all do consult independent experts that are knowledgeable enough to say, that is nonsense and that doesn't make sense too. You're right on this, and that's true, but not all the time. Anyways, this is all I have for now. This definitely isn't a done deal, but I had to cut it somewhere, otherwise I'd never finish this project. Thanks for watching, and feel free to post a comment. Let's just try to avoid all the blames and flames and hates and trolls and all that jazz. We can do better than that.